Today I want to talk about secrets. But don't go away. Don't go away just yet. I know that for many secrets is either boring or you think you already know everything there is to know about managing secrets. I will not talk about obvious secret stuff. Instead, I want to try to answer some less often asked yet important questions. How do we make secrets easy and irrelevant to users? How do we propagate secrets without making them exposed? How do we generate secrets in one place but use them in another safely? And a few others. Today's video will be different than what you might expect from secrets. Today I want to explore and solve a few problems I was facing not long ago and that I believe I solved without making anyone suffer. Let me explain the problem before I show you a possible solution. I tend to manage a number of resources. There are clusters, applications, databases, and so on and so forth. Most of those generate or consume secrets. Some of them do both. Some secrets were added manually to a secret store like a Google Secret Manager, AWS Secret Manager, Azure Key Vault, or whatever else you are using or I'm using. Others, however, are generated as Kubernetes secrets and not stored in any of those secret stores, which by itself is a bad situation, which I will explain in a moment. So far, you probably do not see a problem. You might be inclined to say that a tool like External Secrets Operator can solve those issues. It can pull secrets from almost any secret manager. If you're already using it, you might even be aware that it can also push secrets to a secret manager of choice. If you're not familiar with external secrets, you might want to watch that video. Just don't do it right now. Finish this one first. If that's what you're thinking, you're right. External Secrets Operator or any other similar tool solves some of my problems, but not all. Let me explain what I need. I have a control plane cluster. In my case, that's Crossplane, and in yours, that might be something else. It could be a simple server from which you run Terraform or a pipeline or anything else from where you do stuff. It does not matter for now. What does matter is that Kubernetes clusters are created, managed, and removed from that control plane. Now, those clusters need to have a number of secrets that enable them to interact with outside services. A good example would be credentials that must be used to pull or even push images from or to a container image registry. Almost every cluster needs some secrets to operate correctly. Now, those secrets should be pulled from whichever secrets manager I might be using, and that means that they all have to have External Secrets Operator, or whichever other similar tool we might be using. However, that operator needs a secret with authentication so that it can fetch secrets from the secrets manager. To be honest, I know that there are many ways to accomplish all that, but I tend to complicate my life by treating all those requirements as baseline requirements, as table stakes. When I do create a cluster, all those need to be there from the start. And I don't want to have to perform many steps to get them. Ideally, I should say, create a cluster, and apart from a cluster being created, it should come preloaded with the External Secrets Operator, credentials it needs, and secrets pooled. I don't want to work to get those. They just need to get there automagically. There's more though. Sometimes I will set up a new database in one place, but run an application that consumes that database in another. I might, for example, instruct the control plane to create and manage a database, and that will, among other things, result in a secret with database authentication being created in the control plane cluster. I don't need that secret there. I need it somewhere else. I need it in the cluster where the application that consumes that database is running. Hence, that secret needs to be moved from one place to another. Actually, that's not correct. It should not be moved, but rather copied. However, I cannot just copy the secret. That would be silly since I'm supposed to keep secrets in the secret manager. Hence, I need to push that secret to the secret manager from one place and pull it from the secret manager to another. There's still more though. I don't want those things to be a burden to others creating and managing databases or applications or whatever they're managing. I want all that to be transparent. No, invisible. I want people to be secure, yet not to have to learn all the details or worry about those things. It should be like magic. People should be in control of things that matter to them, while those that don't should just happen. Secrets or even security in general fall into the I do not care, yet I am safe category. Normally I have quite a few other requirements, but those I discussed so far are enough to give you an idea what I'm trying to accomplish. That was enough talk. Let me show you how I solved those issues. Let me show you how to deal with secrets without making anyone suffer. Before we proceed, I should tell you that all the commands I will execute in this video are available in a gist, and the link to it is in the description. Please use it if you would like to reproduce what I'm showcasing. Right now, my kubectl is pointing to the control plane cluster. Over there, if you take a look at the Crossplane system namespace, we can see that AWS Creds is available. I created that secret manually, and hopefully, that's the only secret I will manage myself. That secret contains AWS credentials, which, for example, are used by Crossplane to communicate with my AWS account to create Kubernetes clusters, databases, and whatever else I need. At the same time, that secret is also used by external secrets operator to pull secrets I instructed to pull. By the way, I made an assumption that you're familiar with Crossplane. If you're not, please watch those videos, or even better, watch the Crossplane tutorial I published as a set of videos a short while ago. The link to the playlist is in the description. Alternatively, you can explore the compositions yourself. The link to the repo is in the description as well. The important note within the context of today's subject is that I need that secret to be available in clusters I will create from this control plane. So let's take a look at one example. And this is the part that makes everything simple for the end users. It is a cluster claim that creates everything required to run a Kubernetes cluster in AWS. If you followed my work, you already saw a variation of such crossplane compositions, so I will not go into details. The interesting part is the creds entry. That one tells Crossplane to take the AWS creds secret and put it into the Crossplane system namespace. That secret in that cluster should contain the creds access key ID and secret access key keys. As a result, Crossplane will create a cluster and everything it needs, and it will copy the AWS creds secret into that new cluster. Now, to be completely clear, that's not the best way to propagate secrets from one place to another. A better way would be to use external secrets operator and instruct it to pull a secret from a secret manager. However, to do that, we need external secrets to be able to authenticate with the secrets manager, and that's the primary purpose of copying AWS creds secret. An important note is that the end user has freedom to choose which secret to copy, to which namespace to place it, and which keys to include. On the other hand, the end user does not need to worry about the details. There is no need to know how it was done and what's the magic behind the process. Further on, we have the open function field, which installs open function in that cluster. That one is not directly related to secrets. However, among other things, open function builds container images and stores them in a registry. For that to work, it needs credentials stored in a Kubernetes secret. By the way, if you're not familiar with open function, please check out that video. Since I already explained it over there, I will not go into details of how it works and what it does in this video. To accommodate the need for a secret with container registry authentication as well as other secrets we might need, there is the external secrets section. In it, we have the enable field that will ensure that external secrets operator is deployed to a cluster, and the store, which will create cluster secrets store resource. That's the one that needs a secret that allows it to connect to the secret manager. That secret is retrieved from the AWS creds we explored earlier, and all we have to do is specify the keys. Finally, with external secrets operator fully operational and capable of fetching secrets from the secrets manager, we are listing all the secrets we would like to pull into that cluster. In this specific case, there is one that provides authentication to the container image registry needed for open function. Now, you might be thinking that the whole setup is not secure, and you would be right. Secrets are stored safely in the secrets manager, but anyone could create a cluster with any or all of the secrets. That's where policies would come in. Typically, I would set up Caverno policies that would define who can do what, and more specifically, who can create those cluster claims and which values are allowed. That, combined with the fact that secrets are safely pulled from a secrets manager, makes it pretty safe, except the fact that Kubernetes secrets themselves are not always safe, but that would be a subject for a separate video. The good news is that the end users do not need to worry about any of the things we discussed. All they have to do is write those 30-something lines of YAML and send it to the Kubernetes API. So let's do just that. Now we can observe what's happening with the Crossplane trace command. Quite a few resources were created in the control plane cluster. Some of them will create and manage AWS resources, others will create stuff in the control plane cluster, while some will set up things in the new cluster once it's operational. You will notice that quite a few resources are having errors. That's okay. Some of them, like, for example, namespaces cannot be created yet since the cluster where they should be applied is not yet operational. Everything will be eventually consistent. And while waiting for that to happen, we can focus on the few of those resources related to the secrets we discussed. By the way, I explored eventual consistency both from the theoretical and from the practical perspectives in those videos over there. So please check them out if you would like to understand better what I meant by all this, by eventual consistency. We have the A-Team cluster creds resources that is copying the hyperscaler credentials from the control plane cluster to the new cluster. That's the one external secrets needs to authenticate with the secrets manager, which in my case is in AWS. Then we have A-Team cluster secret store that will create external secret store that uses those credentials. Finally, there is the push secret that will be pulled from the secrets manager and which will be used by open function to push those images. That's it. That was yet another explanation that matters to you, the person that builds, who builds services like the one we are exploring today, but not to the end users. They do not need to care, yet they will be safe. All that's left to do is to wait until all the resources are up and running. So let's fast forward and trace the claim one more time. There might be a problem with open function. It is still in creating state, or to be more precise, Crossplane thinks that it is creating, but it's probably up and running. It's a massive Helm chart that takes ages to deploy, and it's probably timing out. I'll fix that later. That's not relevant for this story. What does matter is that we can now retrieve kubeconfig and retrieve secrets from the Crossplane system namespace. It's there! The AWS cred secret was auto-magically created in this new cluster. We can also list the external secret store and observe that it was created correctly. The fact that the status is valid means that it was able to connect to the secrets manager in AWS in this case. We can also list external secrets resources and observe that push secret was synced. That means that it succeeded in pulling the registry secret from the secret manager. We can confirm that as well by retrieving Kubernetes secrets from the production namespace. The push secret is there. That's the one that contains the authentication to the container image registry open function needs. What did we do? Let me paint it for you. Let me show you a diagram of what we did. The control plane cluster contained Crossplane and a secret with the AWS authentication. From there on, we applied a Crossplane composite claim that created a new Kubernetes cluster, in my case, EKS, with everything that it requires. The secret from the control plane was copied to the new cluster, and external secrets operator was installed and configured using that secret to communicate with the AWS secrets manager. Finally, external secrets operator pulled the secret with credentials from the container image registry, which will be used by open function that was also installed and configured inside that new cluster. But, here's a big but, that's not enough. I have a potentially more interesting example to demonstrate. Databases are special. They often do not run in the same place where applications are running. For example, I might have an AWS RDS database and an application running in a Kubernetes cluster. If RDS is created with Crossplane, Crossplane will create a Kubernetes secret with the authentication details. However, that secret will be created in the control plane cluster, the one where Crossplane is running, while the application that should use it might be running in a different cluster. That means that we might need to safely propagate the secret from one cluster to another. Ideally, we should not just copy the secret, but push it to the secrets manager and pull it from there wherever we need it. That's exactly what we will do next. And I already prepared a composition that will do just that. So let's take a look at the manifest that will claim it. That manifest will create a PostgreSQL server and everything else needed for it to run in AWS, a database inside that server, and quite a few other things. Those are not important right now. What matters is the secrets section. By the way, please let me know through comments in this video if it would be interesting to explore database as a service in one of the upcoming videos. That claim will create a secret in the control plane cluster, the one that runs Crossplane, but as I already mentioned, we need it elsewhere. That elsewhere could be the new cluster we created earlier. It already contains open function, which is a great way to define, build, and deploy applications which might need to connect to a database. Hence, we need the secret in that other cluster. The store name defines the external secret store. That's the one we created earlier when we created the cluster. RDS requires a root password, so we are fetching it from the AWS Secrets Manager through the pull root password key value. That's similar to what we did before. The interesting part comes next. The push to store parameter tells the composite resource to push that secret it will create in the control plane cluster to the secret manager, the one in AWS. External secrets operator, which we are wrapping here, has the capability not only to pull, but also to push secrets. Further on, we are telling the claim to pull the secret from the secret manager into the production namespace inside the A-team cluster. Let's apply the claim and see what happens. First, I will unset kubeconfig so that kubectl points to the control plane cluster and apply the claim. Let's see what we got with the crossplane trace command. Among others, we got the secret pull resource that pulls root password from the hyperscaler's secret store. Then there is the push store resource that pushes DB secret to the secret store, and finally the pull cluster resource that pulls the secret with the creds to the other cluster. It will take a while until all the resources are available, so let's fast forward and trace the claim again. All the resources are available and we can take a look at what we got. To begin with, there should be the secret with the root password in the control plane cluster, since that's the data Crossplane itself needs. We can see that the external secret was created, which in turn created the MyDB Kubernetes secret with the password pulled from the clusters, not clusters, but secrets manager. Once the database server was created, Crossplane created a secret with the IP, port, username, and password that can be used to access the database server. Since we need that info in the other cluster, the one where the application that might use the database should be running, the composite resource created the external secrets push secret, which in turn pushed it to the secrets manager. We can confirm that's indeed what happened by going to the AWS console, and there we go. The secret was indeed created. Finally, the secret should be pulled into the other cluster, so let's export kubeconfig again and list all external secrets in the production namespace. The MyDB external secret is there, and you know what that means, right? If we list the secrets in the production namespace, we can see that it was pulled from the secrets manager. So what did I do? What did we do? From the control plane cluster, the one with Crossplane, we created a composite claim that created all the AWS resources required to run RDS database server, and it created database inside it. Among other things, the server needed a root password, so the composite resource created an external secret, which in turn pulled the root password from the AWS Secrets Manager and used it to create a Kubernetes secret. Once the database was created, Crossplane created a secret with the connection info. Since we needed that info in a secret in a different cluster, it also created external secrets push secret which pushed it to the secrets manager. Finally, it created an external secrets in the cluster where the application should run, which in turn pulled the connection info from the secrets manager and created Kubernetes secret. From there on, an application can connect to the database from that cluster by simply mounting the secret. Whew. That must have been overwhelming, but hopefully useful to see what can be done by combining Crossplane with external secrets and a few other tools. Thank you for watching. See you in the next one. Cheers.